necessarily. That'd be kind of cool. Because we have the dots for roles in the IETF. It'd be nice if we had some dots, or at least some tags I can give roles in the working group. I'll talk to Echo. It's worth asking for. Okay, we're right at the start time. I think, let's see, a first presenter. Human. I don't see Human here yet. Just give a little bit. Tony, kick when you're back. Human, if you're here under a different name or group or something, just speak up so I know you're here. We can think about getting rolling. Excuse me. Navarro, I just replied to your email. We can talk about again the list in the room today if you want. But, I think it's pretty much all there.
Thanks, Greg.
Thank you. Okay, Tony's back. Still looking for Human. He's our first presenter after our status.
Hi, Greg. I'm here. Can you hear me?
Oh, yeah, I hear you. Excellent. Thank you very much. All right, Tony, you see any other reason why we shouldn't get rolling?
Hi, everyone.
All right, everybody. What I've got is a question on process, actually, if you can give me some feedback here, Alvaro. On taking notes now, I've got the little notepad thing up. Is the intent that people put their own stuff in there, or we have someone directed and everything's done at that tool? Is that with the intent with minutes?
No, so ideally, we would do the minutes the same way as before, right? You would have a minute taker.
Yeah.
The advantage of the shared minutes or the shared place there is that then I can go there, for example, and add the question that I asked, or clarify something, or spell my name correctly, or whatever it is. So there's the opportunity for other people to help, but ideally there should be someone responsible for that.
But that one person should be working on that doc as well.
Right. Ideally, there would be someone.
What we did before, just open up a text pad and start writing on stuff, right? Or a Word doc. So now we do it before we have note taker, but they do it there, and everyone else can go in and make corrections or add their own questions. Okay. So that means we need a minute taker, a volunteer of some kind.
To throw something in, I saw with the other working group was that they actually also take the chat and they paste it after the minutes into this notepad stuff, which I like a lot.
Sure, but that means we only get the minutes from the notepad.
No,
people still will be speaking. Someone still needs to type in there. We still need a note taker.
Yeah, of course. So,
okay.
Minute
so we still need a volunteer.
Yeah, shortcut to path and fame.
You guys are the toughest.
No one here wants to be famous, people.
No.
No ambition. Going once, going twice. Oh, man. All right, I'll take a minute.
Can you do it? All right, thank you, Tony. At least now it's up in that doc now. We'll know where they are. Excellent. All right, so welcome to Beer. Welcome to, well, whatever time zone you're in, and pretend that you're not there. If you're in the wrong room, stick around. We have fun here. Note taken. Nods in the room. I wish I could see y'all. I assume you've read this. Fair assumption? Thanks. Jabber Minutes Collaborative. So that's the URL right there. I've got it up in a tab. I recommend everyone do the same so that when you have questions, you can either put them in there or you can make sure that they were entered correctly if you didn't do them yourself, as Alvaro mentioned, correct names, spelling, what have you. But that's a great way to ensure we have everything in one place from everyone who contributed. So take that down, open a tab, and get ready to have some fun. What's the status with Jabber then? Do we have? I remember seeing yesterday there was some sort of Jabber button somewhere here. I thought. Okay, go to Alvaro.
So the chat that you see in Miraco
That's
is
Jabber.
connected to Jabber, correct? So you could be on Jabber.
Okay, so we'll see the
little. I was going to say there's also a new tool that the IETF is using that is also at the very end, Solibot, I guess. It's the new IM thing. If you guys know where the Jabber logs are, all of this goes into the log as well. If you don't know, that's okay.
The Jabber what? I didn't catch that.
The Jabber logs.
Logs.
So everything on the Jabber is logged and saved.
Okay. And then that's what we then import over into the hedge. All right. Excellent. Okay. Tony's got minutes. I want you all to feel really guilty about that. I don't think that sunk in, but it's worth a try. And here's our agenda. We made a lot of progress last meeting in terms of we have a bunch of stuff that needs shepherds. We have a bunch of stuff that needs adoption call. We had some drafts actually make some progress. To be completely frank, it's been summer and I've been gone and I've been as offline as much as I possibly can. So some things progressed, some things didn't. Now it's cold and wet and I'm stuck inside, and I think we'll be making some progress after this. All right, anything missing from this agenda? All right, Human, you up? Oh, go ahead, Alvaro.
Hey, thanks. I just wanted to say I don't think there's anything missing in the agenda, but what caught my attention, and this is really for the whole working group, not just to you, Greg, or Tony. We're not going to have time, right? We have 40 minutes if time permits, and unless I shut up right now and everyone does it very fast, we're not going to have it. It seems that maybe we can have an interim at some point. It seems that everyone took the summer off because the list has been very quiet, and we can't make progress with a 10-minute presentation every 4 months, if time permits, right? if I have enough time to do that. So what I want to say is that it's up to all of us, the authors and the chairs and people who are not authors who can review documents, to make these things progress, right? Because there's no way that in 10 minutes we're going to be able to get an update, dig into the issues, and resolve them here. We have to go to the list, right?
Can I add to that complexity? We don't even have time after this where we BS in the bar and do it as well, right? So it's even worse than a normal meeting.
Correct. So we want to, or we need to, I think, as a working group, to be a little bit more active, for all of us, to again, sponsor or push discussions, the draft authors and you guys as chairs to make sure that the discussions happen. And as I said, even for the people who are not authors, we need you to review documents so that they are well understood and well reviewed by the time they get out of the working group. So that's
this is our longer gap anyway, so it makes sense. I think what I've done in the past in groups when we start getting wedged, I think we did it here with beer as well. Like late January seems like a good target. We get everyone to agree before they disappear on the holiday, come back, give them a few weeks, get their heads together, and then we can meet again and make some progress. So we'll make a determination on the list as we see things move, but that's a great suggestion, Alvaro. Appreciate it. Curious too. Well, never mind. We'll just move. We don't have enough time. So, Human, are you ready? Can you do the preloaded slide?
Yeah, if I can click on the unmute, I'm ready. Which I think I just did.
Greg, you had a question?
I wanted to ask about in course of discussing progress of PathMTU discovery in BIER, what I found is that we kind of stuck with the BIER ping document. I'm afraid it's expired. So I would really appreciate help of chairs and AD reaching out to the pen holder and asking of status and if need some help. If the pen holder needs help, I can help and edit the document, because to progress PathMTU discovery and BIER, we need to finish the ping document, or at least they need to move together.
So you're one of the authors, aren't you?
Yes, I'm a co-author, but I'm not pen holder.
Okay. Well, hopefully you guys are in communication as well. I mean, we can kick, but you're entitled to as well.
Yeah, that's kind of not working.
Okay. You need another boot or two. All right. Well, that's my intent after this meeting, going through all the docs and see where they are. Sandy put together a fantastic list for us last time, and we moved some of that along, and we'll just go from there and probably get comment from the entire group on the list of where these docs are, and we'll start moving this stuff, because that we're going to need that anyway to kind of see what progress we make before we get to an interim, to see, you know, what extra things we need to do, which ones we need to focus on, etc. So
yeah, I greatly appreciate Human's volunteering to shepherd their PathMTU discovery, but yeah, we'll need to progress the ping too.
Excellent.
Thanks.
Okay, Human, were you waiting for me to authorize you to do something? I just hit the.
No, I send you folks a slide, so I don't see them being shared on the. Or
so if I stop sharing slides, I think that's a start. You go up there and there's a share preloaded slide button.
Oh, okay. Now I need to get on another PC. I thought I sent this. I thought I sent this slide, Sandy. Yeah, if you could share it, I would really appreciate it.
Okay. So this is actually a pretty cool tool. You hit this, everything that's been that's why I asked to get them all up ahead of time, so we can just pop through this. So I'll hit this. I'll select your, you BIER MLDP. I'm going to go back over. No, yeah, MLDP. Excellent. All right. So that is on top of the queue on this doc. Boom. And share. And I'll step through them for you. What did it do? I'm stopping sharing. Okay. I'll try it again. MLD share. There it is.
Wonderful. Perfect. So I think a couple of IETF ago, I went through this. I think we asked for last call because we haven't got any comments or any questions on it. We were hoping that the last call would start generating some comments, questions on the draft. I personally didn't see the last call email going around, so I thought maybe it's good to give everybody another refresher on what we are trying to do on this draft. So if you could go to next slide, please. So this is this draft is really V2 of the PIM signaling over BIER. We are trying to achieve the same thing with MLDP over BIER. The entire point of this draft is that if you do have a customer that or an operator that wants to go from some of these legacy multicast protocols to the BIER, they probably want to upgrade some of their part of their networks one at a time. Usually they might start from the core or whichever part of the network it is, and this draft will make it easier on them to upgrade a part of the network on the MLDP network to BIER without really changing the software on the routers that are doing MLDP. or really doing any excessive configurations on any of these routers that are doing MLDP. You just grab the portion of the network that you want to upgrade to BIER. You upgrade it to BIER because of the hardware supports BIER, and any portion of the network that doesn't support, the hardware doesn't support, or the software for that matter, doesn't support BIER forwarding, can stay on MLDP without any excessive software upgrades or any change in the topology of the network itself. Next slide, please. We are using RFC 7060. Basically, we are using TLDP between the two BIER edge routers to communicate the FEC from one MLDP domain to the next MLDP domain. So when the FEC comes into the one of the BIER edge router that is terminating the LDP signaling, that BIER edge router creates a targeted LDP multi-hop away to the another BIER edge router, which is the egress. Even I forgot the terminology since it's been so long. It's a egress BIER edge router, so that becomes EB edge ER, EBER. I think that was the terminology we used, and signals the FEC, and then we push that FEC into the MLDP domain, and based on that FEC signaling, BIER can figure out who are the BIER peer routers that MLDP is terminating on, and can set up the BIER communications between the two edge routers. Next slide, please. So as these FEC signalings, they come in from downstreams, the ingress BIER edge router, if you will, builds the tree, figures out who are the peers, and it builds the BIER neighborship. And actually, when the packets come in, the MLDP packets, they come in to the edge router. We swap the label with the TLDP label. We push on the BIER header, and we go downstream to all these other BIER routers that were actually signaling their interest into that FEC and into that source of the multicast. And that's basically how the data path starts working. When we get to the downstream BIER edge router, we pop the BIER header. There is a protocol, the BIER protocol, which is the MPLS. And based on that, we realize that there is a label that we need to swap with the downstream MLDP domain, if you will. And that's how the data path starts working. Next slide, please. So this was a good refresher for myself too, actually. So basically, again, we are looking for any comments, any suggestions. If anybody in the working group feels that we need to beef up the draft, by all means, come on the mailing list and let us know. If not, maybe we should do a last call, and maybe that will trigger some extra discussions. And that's all for me. Thanks.
Questions? You gotta turn your mic on.
So this is Loa. One thing is you could send you could send a mail to the MPLS working group and ask for comments also. I had read the draft. There are almost no changes that is significant for MLDP, but it might trigger some responses at least. And to the shares for BIER, I would like a mail to go to the MPLS working group when you start the working group last call for this draft. Okay, thanks.
In parallel? You're asking in parallel?
Oh. When you start the working group last call, just send a mail to the MPLS working group, telling us that you have started the working group last call. Yeah.
Okay, gotcha. Just inform the list so they can jump in and take a look as well.
Yeah, and actually they should direct comments to the beer list, not to the MPLS.
Yeah, exactly. That's what I was saying. Is it was last call in our group. Comments should start there. But it depends on the integration. But oftentimes it then goes over to the chairs of the other group for approval, as before you take it up to publication.
No,
but having early feedback is a good idea.
At least one of you is subscribed to the MPLS list. Just send the mail.
Yeah, absolutely. All right, thanks for that suggestion. Alvaro?
So you can just CC also MPLS on the last call. Also, can you please copy Bess, just in case there's someone there that wants to take a look at this as well. I have a question. I was going to say I have a question about the draft itself. I haven't read it, but it is marked as informational.
That's yeah. Thank you. I need.
So I guess you're saying you're going to change that.
Yeah, my apologies. Yeah, I think that might have been a copy-paste mistake. I will change that, upload it again.
Yeah, the other thing that I noticed is that there are no normative references in the draft. So please check that, because there should be normative references.
Yes, thank you. I'll check that too. Thank you.
Thanks.
Yeah, thanks, Alvaro. Any more questions on this draft and prezo? 3, 2, 1. All right, thanks, Norman. Next up, we have the PCE-based beer. We see 2 presenters, either one of you in the room. All right, grant preloaded slides. There it is. Okay, I didn't see that before he hit the button. Now that makes sense.
Hello, everyone. Can you hear me?
Yep, we hear you.
Okay.
All right, we see the deck.
Hello, everyone.
Yeah, okay, excellent. I'll go mute. Go ahead.
I'm Huanan Li from China Telecom. I'm going to introduce our updates. Some comments were made at a previous meeting, including objects format dense, and it is suggested to break this PCEP objectives down more. In this update, the overall process has not changed. Our main change from the previous version is to put some duplicate fields into TLVs, increasing the extensibility of these PCP objects. We defined 4 new TLVs, namely multicast source address TLV, multicast group address TLV, VPN information TLV, and beer information TLV. Among these TLVs, VPN information TLV contains RD and forwarding label. The label length can be set to 0. Beer information TLV contains router identification information in beer domain or subdomain, specifically subdomain ID, BFR ID, and BSL. The multicast source registration object can be used in both beer and non-beer scenarios. In beer scenario, it should include other 3 TLVs, exclude multicast group address TLV. Multicast receiver information object can be used in both beer and non-beer scenario. In beer scenario, it should include all these 4 TLVs. Forwarding indication object contains beer forwarding information, specifically subdomain ID, SI, BSL, and bit string. FI object does not need to carry beer information TLV and can only be used in beer scenario. It should include other 3 TLVs. Multicast receiver state objects does not to carry VPN information TLV and beer information TLV can be used in both beer and non-beer scenario. It should include multicast source address TLV and multicast group address TLV. That's the main content of this draft. But in addition, in last discussion, Tony mentioned the flag is not generic enough. Could it be more specific? Any comment on our work are welcomed. Thank you.
Okay, no cue. Then I comment as participants. So read the draft with great interest. All cool. I think it should be more precisely named PCE, IP multicast beer overlay or something, because it only does traditional IP multicast on top of beer. But I mean, that's cool. I have a specific question where I stumbled in the draft, where you have this forwarding indication object and you passing around the beer bit mask. That's all cool, but there is a B bit which you can set and indicate non-beer. So that confused me. Why would you pass around the beer bit mask if it's not beer? If you don't have it from the top of your head, then I just take it to the list.
Hello? Yeah, Tony. The forwarding indication object is mainly used for the beer scenario currently. For the non-beer scenario, I think we should define other similar object to detect the BIER to how to reach the receiver.
Still does not make sense to me why a beer bit mask would be passed around then, but it's okay. I'll take it to the list.
Okay, no problem.
Just general comment. I'm happy to see this as one of the initial architects of beer, even before the BOF. We were seeing all these scenarios, and this is one that came out, basically, the signaling over the top. And I guess the question I have going forward on this is, do we want to make this the definitive document for all PCE regarding beer, or just this particular scenario, and then just pick things up as they come down the road? Just general. I'm not looking for an answer. I'm just thinking something to think about, and we'll take that to the list as well as we move this thing along.
Yeah, I think it would be great if that will be kind of the container document for a PCE-based architecture, but ideally it would allow to do something else than just IP multicast.
Yes, that exactly.
So no, just a hook to allow to differentiate and plug something in which is not based on IP multicast addresses would be, an excellent extension, I think, and that would then basically define the architecture for PCE beer, over PCE. Dhruv, go ahead, please.
Dhruv?
Can you guys hear me?
Yeah, go ahead.
Yeah, thank you guys. The issue that I have is, oh, I'm sorry, I'm posed the question in the chat, and you guys can continue. I'm having some audio issues.
We hear you now. Oh, he's gone. All right. Try again.
A lot of feedback. That's why I was canceling. So I know my voice is clear, but a lot of feedback for me.
Okay, no problem. Thank you. We'll go to the list then. All right. Any more questions? All right. Next up, Jeffrey on slicing. You're granted. Here it comes. All right. I'm off to mute.
Okay. So this is about some thoughts on how to do slicing and traffic differentiation in beer. I'm presenting on behalf of the co-authors here, Jeffrey and Tony. Next slide, please. Am I sharing it myself, or are you running? Looks like I need you to run the slide. Oh, okay. All right. So the it's the arrow on the screen, not the arrow on the keyboard. Okay. So can you hear me?
Answering your
Hello?
questions on the slide, but I realized I was in mute, and so you figured it out before I unmuted. So go ahead. You got it.
Okay. So some slicing backgrounds. From the IETF network slices framework spec, IETF network slice is a basic logical network topology, and traffic associated with the slice is identified with the slice identifier in the packet itself. And then there is extension to that in this draft best bar, where it introduces a concept called the slice aggregates, which comprises one or more IETF network slice traffic streams. Now notice that here slice aggregate can be any of the following, which including entire slice or a set of entire slices that share the same logical topology, and or just some flows in a particular slice. It's very flexible. So a slice aggregate will get per hop forwarding behavior specific to that slice aggregate, which includes the next hop that you use to reach the destination, and some queuing treatments and other things. And now some related to beer background. So in beer, you have one or more beer subdomains that map to a topology. That's N2 mapping. And then each subdomain will have a corresponding BIRT, beer, the routing table used for beer forwarding. That's one-to-one mapping. That BIRT is calculated according to the topology that subdomain is on. And then when you consider the B-string length, and then when you need to use multiple sets because the number of BFERs is greater than your B-string length, then you need to have multiple sets, and there the each bit will correspond to that tuple, subdomain, B-string length, and set ID. Now each BIFT is identified with by an opaque 20-bit number called BIF ID in a beer package, which could be a label or be just any other opaque number. So beer forwarding is based on BIFs, which is derived from the BIRT, BIRT. So you can say that beer forwarding is based on the BIRT. But the important thing to notice here is that for a particular subdomain, all packets, regardless of the flow, all packets to a particular BFER are forwarded to the same next hop BFR or same set of ECMP next hop BFR according to that BIRT. So that BIRT will determine the next hop, and then after that, you can use traffic class bits in the MPLS label entry, or using the DSCP in the beer header to determine other behaviors like queuing. So now, how do we, within that background, how do we do slicing with beer? Now, if a slice aggregate corresponds to a single slice or to a set of slices that share the same logical domain, then there are two ways to do it. One is that you map that SA to a subdomain. With that, because the subdomain ID is only 8-bit, so that means that you can only do 256 S8s. Now, if you want to do more than that, there is actually you can map SA slice aggregate to a BIRT directly. Now, the BIRT will map to the tuple subdomains comma SA instead of just mapping to a subdomain. However, when you note, if you consider that BIRT is calculated on the topology, and that SA is corresponding to a topology, then this extension of mapping a BIRT to subdomains comma SA is a reasonable extension in the BIR architecture. Now, when you use when you map SA to a BIRT directly, that means that in theory, you can support 2 to the power of 20 SAs, as long as your device can hold that many entries. So now, mapping the SA directly to a BIRT instead of the subdomain is desired even when you have fewer than 256 SAs, because when you have fewer subdomains, you don't need that much provisioning related to subdomains. For example, you need to you do not need to assign BFR IDs for each subdomain. To do that, we need the corresponding IGP or BGP signaling extensions. I'm not covering that in this presentation, but it's talked about in the drafts using the ISS or OSPF example. Now, the slice aggregation selector. Oh, I forgot about to mention that that is the defined in the draft bestbar spec. It's basically identifier in the packet that identifies the slice aggregate. Now, in this case, the slice selector will map to one of the beef IDs. Now, what if you need to finer granularity for traffic differentiation, where the SA is only for some flows in a slice? In that case, the slice aggregate selector will map to the to some traffic class or DSCP bits. But if that's not enough, then beer extension header will need to be used. The proto code field in the beer header can indicate that a beer extension header followed, and one of the beer extension header will carry the slice selector to identify the slice aggregation. So now, beer extension header, it has never been discussed here in the beer working group itself. That concept was introduced in this int area or function, generic delivery functions. I'll talk about it briefly here. It's still a developing idea for the purpose of doing generic functions at different layers. For example, fragmentation reassembly and security features, ESP, or in situ OEM, and new use case here is the traffic differentiation. We want to be able to do all these generic functions across different layers, whether it's IPv6 or beer or MPOS or whatever. We also try to align the MPOS beer extension headers with the IP extension headers structure, because the idea is that we want to do this across different layers. So it's better to align those extension headers as much as possible. So that draft has some talks about the both MPOS and beer extension header, but that's just a container draft, and the specific MPOS extension header and the beer extension header will be discussed in beer. It's just we have not officially brought it here yet, but this is like a teaser here that's we will start talking about the beer extension header. So yeah, next steps. We introduced this concept here, and in the drafts we did provided the signaling for either ISS or OSPF, and we will need to specify all those details for the other signaling protocols, and more importantly, we will want to start talking about beer extension headers in beer working group, both for this purpose and for other purposes. Obviously, we appreciate the comments on this. So that's the presentation. I'm open for yeah, question and comments. Yeah, I guess Torres.
So one of the cool things we can be doing better is better QoS. For example, the per flow stateless QoS, which I was presenting in TSN and that sorry, in that networking group, and I was actually also explicitly referring to the problem that we need extension headers that support these mechanisms better, and that it would be great if we wouldn't have to reinvent the wheel between MPLS and IP, and obviously also beer for these type of QoS extension headers. So, and beer specifically, of course, is the of course better even with BeerTE, the technology to allow the stateless multicast replication to go along with the stateless QoS that would be driven by an extension header.
Yeah, indeed, that's the intention of that generic delivery functions drafts, and better QoS across treatment across different layers. That's one of the use cases here. Yes.
And I think what we're missing out, and I think that's for us to go on Friday and see what happens with the hop-by-hop header for IPv6, is how we can try to see, how not only get buy-in with the MPLS design team, but come up with a proposal that also would be accepted by 6men, 6up, whatever the V6 side is. I think your proposal to the MPLS design team was targeted to support that, but you weren't very happy to attack the V6 side in terms of trying to see whether they actually move.
Yeah. Yeah.
All right. Another mic question.
Yeah, I think Shesong is in the queue.
Shesong. I don't know if you're speaking. We can't hear you. She's on. Can you check your mute? And he's back again.
Sorry, I will just go to the chat box.
Nope, we hear you now.
Great. Jeffrey, I remember there's a document in beer working group about the FlexAggle for beer. What is the relationship between these two documents?
I guess I will need to read that document first. I did not see the connection there, but now that you bring it up, I will go read the drafts again and then see if there is any connection.
Sure.
Thanks.
Human.
Yeah, on the same lines, the IPA and the FlexAlgo stuff on the beer, I thought we were trying to solve the same type of issue with them, that you create a FlexAlgo slice, if you will, blue, red, whatever, and each subdomain is being binded to that slice. Now, honestly, I haven't read this T's IETF network slices. I'm not even sure how they're trying to identify a slice. Like, it might make sense in IPv6, but in the MPLS world, I need to go to read the draft. But yeah, just for the working group, that IPA and the FlexAlgo stuff, that I think that was the idea behind it too.
The FlexAlgo may be used as the control plane signaling protocol for to define the topology. I think right now this draft mainly talks about how in the data plane we can have slices. But I will go back to that FlexAlgo draft and IPA bar stuff and to see the connections.
All right, Sandy, the question. Check your mute.
Hello?
There we go.
Hello?
We're here. Yep, go ahead.
Okay, I think it's an interesting topic, and I read the FlexAggle beer draft and this draft both, and I think that the FlexAggle is aligned with the subdomain. So one FlexAggle is equal to one subdomain, and this draft is take effect in the subdomain. So I don't think it's the two is conflict, if I understand right. Oh, that's my opinion. Thank you.
Any more questions? With Jeffrey?
Okay, thank you.
Okay. Next up is Torless. You got the next two prezos, Torless. So hopefully you can be able to grab those as well. Torless. There we go. Granting.
Still my best friend. Okay. Share. Right. So reclaiming time for the working group. So there is no 11, unfortunately. So we got the complete ISG review at the end of August. One discuss, which is easily cleared. There was a typo in the pseudocode. Thanks, Benjamin. And a long list of good comments from 8 reviewers. And then, unfortunately, an unexpected busy September, October with conflicts like me being on NomCom and see next slot. So I'm working through the 11 as we're speaking and hope to have them out soon. I really want to take the opportunity for the comments to also improve the document. There was, for example, from Benjamin this thing that he was always confused about when we're talking about beer, what was meant. So in terms of, is it the overall architecture that is inclusive of BIER-TE, or just the non-BIER-TE, as he proposed me to prefix it. So that reminded me of writing text where I had to write IP unicast to make it easier, clear what I meant when saying IP as opposed to IP multicast. So non-TE beer. Yeah, so that was the only kind of thing I wanted to mention from that. All right, so but yeah, so should easily proceed because it's all comments and the discuss is simple. Okay, next presentation. Stop sharing slide and give me one more. Okay, right. So this is a mouthful, kind of why write a document if you can write everything into the title. Carrier grade minimalist multicast using BIER with recursive bit string structure addresses. And this is actually based on the work done by a team of colleagues in Beijing. And you'll see immediately why they wanted me to write the draft up for this, because it's really kind of BIER-TE next generation, and which of course leaves the question, what the heck is wrong with BIER-TE? And BIER-TE is, in my opinion, the best forwarding solution for the target constraints. And the target constraints were that we obviously wanted to have steering for a BIER, and we didn't want to change the forwarding plane at all. So we ended up, for some particular options in BIER-TE, to have very small changes, like the do not clear bit or so, but in the end it is pretty much like the BIER forwarding plane, and that was the goal. And that, unfortunately, as we've seen working in the working group through all the comments and concerns about scalability, does lead us with a lot of complexities in BIER-TE. The fundamental reason is that we have flat bit strings in the packets, which can address only, let's say, a total of 256 bits. And then part of that is for BFERs, and part of that are for adjacencies like links in the topology to get across. And splitting up the topology so that you fit the bits into this is a problem in BIER-TE. Makes a controller complex, makes it really important to save the number of bits that you're doing. Same issue exists to some extent in BIER, but less severe. So especially for BIER-TE, that flat bit string is really something that makes the controller plane difficult with all these options that we have, like ring bits and point-to-point bits. Kind of, you don't see it in the forwarding plane because that's simple, but the controller plane is difficult. And then also you may end up requiring a larger number of copies because you need to split up the topology across more bit strings than you actually would need, because you can't fit them all in a single bit string. So ultimately what we have operational, both for the humans and the controller software complexity, less traffic efficiency for forwarding plane simplicity. So, which brings us back to what is actually the vision that we wanted to get with BIER, in my opinion. And so this is what we gave the visionary name for the service providers, for the carriers, right? We want to have really a minimal multicast solution that really becomes simpler. So controller does help to simplify a lot of things. And when we, for example, also manage to eliminate the duplication between BIER and the flow overlay by extending BIER or the control plane all the way into the senders and receivers, so that they don't have to bother about IP multicast at all, and all the overlay signaling, then we're fairly fine on the controller plane. I think we can also afford some more intelligent forwarding in the forwarding plane. And this is basically what this draft is primarily about, because this is just the vision part. And that is effectively why the heck can't we basically make the bit string a structured a data structure in which we effectively replicate the distribution tree that we want the packet to have, right? So if you want a packet to be replicated from R to 1, 2, 3, and to N, and then from 1 to, again, some number of BFRs, well, we can basically encode that in a structure. So, and that's shown here. You have a fixed field in the beginning. You have the bit string for the local node that is processing the packet. And then you have a sequence of, what we call recursive units, one each for each BFR that you are sending the packet to. And of course, once that packet is forwarded to one of those BFRs, you are going to rewrite the address. You're pretty much extracting the recursive unit for that neighbor from the address and make that become the new address, and that's what you're sending the neighbor. So what the neighbor then gets is effectively its recursive unit, which again has the bit string of where it should replicate the packets to, and then the recursive units for the further hops. And so yes, there is some overhead for the structuring here, right? We basically need to include some type of addressing field that tells us how long the recursive units are. But that is pretty much the only structural overhead. The rest is just bit strings. So instead of having a humongous bit string to represent the whole topology, we're only requiring to include the bit strings for the nodes that the packet actually is traversing. And so here in more detail to walk through, and there is one bug in the picture which I fixed in the draft. So the draft has exactly the same example. And that exactly shows that in all the glorious detail. So when the packet ultimately gets to a client, of course, for the clients, you don't need another recursive unit. So there is a new flag then in the BIFT, which basically says whether or not a particular bit is to a BFR or to punt up and send it to a receiver. That is then ultimately the only complexity to work through. So the draft has, of course, oh, wait a second, this is not the slide yet. So let me summarize here on the slide. First, the simplification and performance enhancement that we're getting. So obviously we don't need loop prevention through the clearing of bits, because by just extracting the recursive unit for the next hop, we're kind of achieving the same goal. So that is for free, the loop prevention. We don't need to split up the topology into different SI or multiple SD bit strings. So the amount of state that we need to maintain on every BFR is minimal. It's just one BIFT sized exactly to the number of bits representing the number of links to neighbors, or if we want to have overlay, of course, tunnels to remote neighbors. There is no need for all the complicated, bit semantics to optimize and limit the number of bits we have across the whole topology. And so this, of course, is especially great for sparse distributions, meaning sparse multicast trees. And I think we know that most multicast trees are sparse. The network is large, but the number of receivers we need, they may be anywhere, which is why, we had problems with the BRTE. But they will be small, so they'll very much likely fit into a single packet header of maybe up to 512 bits. And then if really the total number of receivers gets larger, then the controller can very easily split up the whole distribution tree into any subset of receivers and build the distribution tree for that, because there is no further cut up of the bit into different SI and SDs. So those are all the simplifications for the controller plane that we get with this. So all the complexities that we hated when working through BRTE are gone with that. And now we have the cost of business, of course, in the forwarding plane. And so this is the pseudocode. And so there is a little bit of calculation in the beginning for the packet, but when you look on the right-hand side, the replication, then of course the only big complexity is once you have calculated the offset and length of the recursive unit for each packet copy, you need to do the rewrite of the packet header and extract that address field and make that become the new destination address field. So that is exactly, I think for forwarding planes, the interesting question, is that already now, or at which point in time, and what type of routers would that be sufficiently easily feasible to be productizable. Other thoughts? So this is, of course, a natural variable length address structure for versus the naturally fixed size in BIER and BIER-TE. But sorry, shut up. Okay. So yeah, so I was talking about the forwarding complexity. So I think one of the interesting things to do, and that would of course be great for researchers to also jump into that, to do really the simulation comparison of the number of bit strings we need, the size of bit strings, and so on between BIER, BIER-TE, and this RBS solution. The packet encoding, packet header, of course, not purpose of this draft, like all our documents. It could, of course, use RFC 8296 and be considered yet another BIFT mode, right after BIER-TE also includes the notion that BIFTs would need to be set to a mode for BIER-TE forwarding. So it could be BIER-RBS or whatever we want to call it. But of course, that would be wasting bandwidth, because we would then use the maximum bit string size. So I think that's an interesting question. But of course, using 8296 would be the fastest way to adopt something like this. And I think that's it. Thank you very much.
All right, we going up? Zhao? Is that Jeffrey?
Yes. So let's say you have to reach 2,000 edge routers. How many bits would you need?
Right, and I think the answer, of course, so first of all, we haven't decided on what the unit of allocations in the bit strings are. So there is a reference encoding option, and of course, depending on the packet header that we're choosing, we would specify that. So here it's assuming for BIFTs to be every bit long, so units of bits, the whole forwarding engine units of bits. That would allow you to calculate that. And then the answer still depends on, are you going to go across 20 hops to the receivers or through 10 hops, right? So I would say that maybe roughly calculated, if you have 2,000 receivers, you could end up with as little as maybe double the number of total bits, 4,000 bits, and then you break it up into the number of packets that you need to make each of the subtrees be sufficiently small for whatever your maximum size is, right? But exactly that goes to the simulation of give me different topologies, and then let's calculate how many bits of addressing we need for them.
Okay, so basically, at least the number of bits, number of receivers. And then depending on how much explicit control you need, you need to add more bits. Okay, thank you.
Yeah, you need more bits, but you don't have the problem in BIER-TE that you need to do a lot of design up front, right? You simply on every BFR you simply have a BIFT. You have 100 interfaces. You have 100 bits. You have 10 interfaces. You have 10 bits. So that is plain and simple, and then the controller ultimately just needs to figure out into how many packets to split it up to send it, right? So there is never the problem of getting through any topology. The larger the number of steering bits are, the more overhead they do. But that's the cost of business of doing traffic engineering, right? I mean, the same thing is true for segment routing, of course.
Yep. Thanks.
All right, TNG.
Oh yes. Hey, Thomas. I saw the similar session has been presented in another working group. I think the Internet Area Working Group. So this is regarding some logistic things. Did you get any feedback from that group regarding your session?
Yeah, I'm trying to remember. This week was so busy, and I would say I have to go back to the notes to remember. There was some feedback. There were some questions, but fortunately, I forgot.
Where was it presented?
So, but I think the whole point was in the int area, there is a lot of discussion about variable length addressing and what their benefit is. And everybody is only talking about unicast. And so I was specifically going there to say that we actually have the best track record in the IETF of what we can do more and better with addressing, even when it was fixed lengths, right? Remember all the things we did in IPv6 with the addressing, and BIER, of course, being a cool new semantic, and this one being a proposal, that expands BIER in a way that we can get more out of variable length addresses. That was the purpose of presenting to int area.
Okay, thank you.
Thanks. All right, Sandy. Mute.
Hello?
There we go. Hear you. Go ahead.
I'd like to know if the bits has been worked in the bit string will be cut. The question is, if the
so basically on every hop you're extracting a recursive unit, right? So every bit string in the structure is only examined by one node, and once it's examined and acted upon, it's not seen in the address anymore, because you're removing all of that before forwarding the packet to the next node.
So your bit string will be shorter and shorter, right?
Yes. So it's like MPLS, right? Consider it to be a bit string MPLS type of operation. You're always discarding what you've used.
Popping it off. Yeah.
Got it. Thank you.
All right. Any more questions? Tony.
Yeah, coming from my side. So first, Torles, your draft names start to sound more and more like folded proteins in biology. You better watch it, man.
I know. I need to stop that. Please help me. Tell me a better name to shorten the draft name. Yes.
Yeah. So that's of course, it's a joke. My question would be, if we even want to look at the adoption of the stuff, is that covered in the charter by the BIER-TE moniker, or is it something else completely? I mean, I'm sympathetic to mucking around with the semantic bitmask if it makes sense. We just need some kind of license, to stretch this story farther. I have no answer. It's just more something that I put into the room. Okay.
Yeah. Well, when we do so, go through that. Let me know so I can help, because I have some other working group where stuff has been lying around with that question for 4 years and they couldn't figure out. So.
I don't think there's anything in there specifically that talks or restricts engineering.
If I have to call it BIER-TE on steroids so that it fits the because I mean it's still all the adjacencies, all the basic the BIFT and what the BIFT does is a simple subset. It's just that the address itself is structured differently, so to remove the limitations. So I would certainly make the very strong point that architecturally it's very much derived from BIER-TE and learned from the limitations we're getting by just using the same address structure that we did for BIER.
Okay.
I was going to say they just call it BIER-TE plus.
Yeah, don't call it
no.
We are a clean working group, okay?
This is let me point out. This is Greg speaking as chair, looking at our charter. There's nothing in the charter that mentions a specific draft or even a name of any kind. It does say in item 8, forwarding plane mechanisms for BIER traffic engineering. The definition of how and new BIER forwarding plane structures can be used to support engineered multicast trees. So, I mean, the read on the charter from my perspective would be, yes, this is completely encased in our charter.
Okay, you just let Torles loose.
Well, it doesn't mean we adopt the draft. I'm not saying I'm for or against.
Okay,
I'm just saying this work is within the scope of our working group.
If it's written that way, seems to be pretty clear. But we have the license.
We have the license.
Right. And I think also, the working through BIER-TE, which will be finished, yes, very soon, I think we also identified the concerns with this, scale and topology engineering, which the draft so largely now documents. And so I think that also should serve as evidence that something that gets rid of that problem would be very useful.
Or at least improves it.
Yeah.
All right, any more questions? So I'm willing to put on 10 more minutes. We have
yes, I can go
TE
through in
LAN.
10 minutes. Try to in 10 minutes.
Go ahead. You're going to show it locally then on your own screen?
Yeah, I can try. I can try share my screen.
Okay.
So can you see my slides?
Not yet, but I'm behind a soup can and string. I'm still waiting. Was the embedded slide not working for you?
I don't know. Okay, maybe you just you show the slides. Maybe.
No, if you go up in the right below your name, in the audio, there's the hand, the note, the screen, the camera, and the mic. Second over from the left is share preloaded slides. That's the dock. If you click that, you can select your deck and show it directly without sharing your screen.
Yeah, click that one. Entire screen.
Go on, Greg, share it so we don't lose time. I have to be going in 10 minutes. I have this thing.
All right. I just unshared his screen, which wasn't coming up. Still trying to get that dock. Want me to do it for you?
Can you see that one?
I don't see you. Do you want me to share it for you? Is the question.
Yeah, just yourself for me.
All right. And there it is. Which one? There's the TE LAN EPFRR?
Yeah, TE LAN, yes. TE LAN, yes.
Okay. That it?
Hello, everyone. Yeah, because today I'm going to talk about the BAT for broadcast link. Next page. So there are issues in existing BAT with multicast links. Egress node on the multicast link may receive duplicate packages. For example, for a TE path from node A to node H and F, node egress H on the broadcast link will receive 2 copies of the same package, one from node G, the other from node C. So in this draft, we propose to improve the BAT for broadcast link to resolve these issues. Next page.
Actually, can we go back to 2? I'm going to have questions specifically about the problem statement. Why would G and C both be forwarding on that broadcast line? That seems like the mask has been misstructured.
No, it's not because mask is disrupted. So just follow the procedure for the BAT, and then egress node will receive one package from G and another package from C. In my draft, I give more details step by step.
But it seems to me if I were sending a packet with the BRTE header on it, and this is what my distribution was going to be, I would not need to include G. It would not need to be set in order to get to that destination.
B will send to G, and then B will send to C.
Yeah, I understand, but why? Why would you set G in this topology? If C is capable of getting it there, you build your tree with your PC, however you've done it, you build your mask, and if you included G in this, there's been a mistake. There's no need necessarily, is there?
Torres, do you want to quickly jump in?
I mean, I can imagine there's a scenario where this problem exists. I just don't see where it is here. That's all. This is more of a problem, it's with the PCE that made a mask that creates this condition.
Yeah, that's
So,
depends.
So I mean, the duplicate packets would only happen when you put more adjacencies than one across the same link. So the controller has always the task to avoid that.
Yeah.
You see here
it's all
we
unicast
only,
anyhow,
we
right?
only,
So
we
all the
only put
traffic
one
is
adjacencies. So that adjacency is 15, right? And then we have another adjacency for 12. 12 is for the destination F, right?
Yeah. So don't include G.
Yeah, for this one, for destination F, we don't include G, but we see distribute that one to F because on the B, node B will not remove the adjacency 15 for G because
we're just
is a remote.
Torres, can you help?
Sorry, I need to wrap my head around a little bit more. Can we take it to the list? I mean,
Okay.
Yeah, take to the list. And then in my draft, I give more details there.
Yeah, go ahead then. Oh, I'm forwarding. There we go.
Yeah, here for a multicast connect to for a multicast broadcast link connect to multiple nodes. So we assume these nodes are connected to a pursuit node PX. For a connection between a pursuit node PX and a real node, we will assign two bit positions, one for non-connected adjacency, the other for forward connected adjacency from pursuit node to real node. So for non-connected adjacency from a real node to pursuit node, that real node will act as a proxy of a pursuit node. So this is similar as OSPF and ISS. For example,
just in the matter of saving time here, right? Just to cut to the chase, is the proposal to have something like the beer packets be layer 2 multicast across the that LAN?
Yeah, this just introduce a proxy nodes. So nodes, the real node will connect to the pursuit node. So this is similar to
are you going to
OSPF.
have? Are you going to have packets being sent as layer 2 multicast so that they can reach multiple BFRs on the same LAN?
No.
You're not. Okay.
No. So this one, just the real node will send the package to pursuit node's next hop. So one implementation is that the real node will fakely send the package to pursuit node is not already sent. So just and then from there, real node will fake or acting as a proxy of pursuit node and then send the package to the pursuit node's next hop. In fact, the one implementation is that real node will have two forwarding tables. One is for main forwarding table, and the other forwarding table is for pursuit node. When for the non-connected adjacency, real node will get the forwarding table for pursuit node and then send the package to pursuit node's next hop. That's the one implementation. Next page gives more details how we achieve this one.
So next slide.
Yeah, next slide.
Okay, let me know.
Next slide, just the one implementation. So node C will have a main forwarding table. It's normal forwarding table, just contain non-connected adjacencies from real node to the pursuit node. And then this node also have a forwarding table for the pursuit node. So this forwarding table for pursuit node is for containing adjacency, forward connected adjacency to the pursuit node's next hop. So that's for one implementation. Next page. Yeah, this gives examples and then shows that we improve the BLT and then we will not have duplicate packages. Next page. Yeah, that's all for this one.
Yes, I have to look more at the examples. There obviously is the option in BRTE for an adjacency or for a bit to have a list of adjacencies to which to replicate. So I'll have to really sit down and compare whether what you're proposing cannot equally be done with that existing option.
Yes, yeah, go ahead. And then you look at the draft and then have details. Yes.
Thanks.
Next page. So right now I'm going to talk about BIER equals protection. Next page. So in BIER equals protection, in previous page covers the case that node backup equals node protect primary equals node, which assume that those nodes are sent their BIER package to the same CE receivers. So this solution is intended to cover another case, which is case B, where backup equals nodes protects primary equals nodes, but these two nodes will send their BIER package to different CEs. So these two cases is indicated by flag. So S flag S equals to 1 means they will send it to the same receiver, which is the case covered in the previous version. S equals to 0 means two nodes will send to the different CEs. This is the new case. Next page. So the solution for the case B, so it's working like this way. So backup equals node protect a primary equals node is configured with a flag indicates whether these two nodes send their BIER package payload to the same receive CEs or different CEs. Flag equals 0 means that they send their payload to the different receive CEs. IGP will distribute this information in the network. So after a PRR, for example, C receives this information, C will extend its forwarding table to contain a backup forwarding entry for equals node F, which considers the flag S. The backup equals node E will create a multicast forwarding table for equals node F, which contains forwarding behaviors of F. In addition, backup equals node E will extend its normal forwarding table to contain a backup forwarding entry for F with a pointer which pointing to the multicast fib for F when flag equals to 0. So at this point, network is ready to provide protections for egress node F. After F fails, both C and backup equals to E have to detect the failure of F. So after detecting the failure of F, node C will using its backup entry to forward the package with F as destination to K. K is LFA to F. K will send this package to E, which is backup equals node. After receiving this package with F as a destination, backup equals node F will using the backup entry in its forwarding table to decapsulate the package, and then using the forwarding table for F to forward the payload of this package to the same receiver as F sends. So next page. Yeah, that's roughly about it. Any comment for this draft?
Jeffrey, you got a question?
So once you do the case B, why do you still need case A?
Yeah, that's a good question. So originally we have case A and then cover most of the cases or general cases. As I think some of people raised the question. So in case that if two nodes send their BS payload to different CEs. So we need to cover this case. So that's the background. We propose this solution for case B. Yeah, you're right. If customer configure their network or planning network only have a case A, then we don't need a case B. You're right.
All right, more questions?
I have one more answer. Case A is simpler. The solution for case A is simpler and more robust. Therefore, that's a reason. That's also a reason to differentiate between case A and case B.
All right, any more questions? We are past our 20-minute push, so we have to wrap this up. We have places to go. Jeffrey, did you just step down? You're done. Are you joining the queue? All right, I think we got to wrap. Thanks, everybody.
Thank you. Appreciate the time for extending the session.
Yeah,
thank you.
Thanks for your patience. And we'll be following up on the list with, well, quite a bit. You guys have a great rest of your week.
Yeah, you too.
Cheers.